Hello students, today I will discuss about the complete solution of question paper of mathematics honors paper 1, that is paper name is CC-1 2021. Here there are 4 parts. In part 1 it is asked to find the asymptotes of the curve yq is equal to x square into 2a minus x. So how to find out the equation of the asymptotes? Now for that, the solution, putting y is equal to m and x is equal to 1 in the third degree, second degree term of the given equation, we get phi 3m is equal to mq minus mq plus 1, because putting y is equal to m in third degree term, that means here if you substitute y is equal to m, so it will be mq minus xq. So minus xq to taking to this side, it will be plus xq, and putting x is equal to 1, we will be getting mq plus 1. And similarly, in putting second degree terms separately, second degree terms means phi to m value is how much? It is equal to minus of 2a, because for x is equal to 1 it is second degree term, so it is phi to m is equal to minus of 2a. Now on equating phi 3 dash m is equal to how much? Phi 3 dash m, that is equal to your 3m square. So on equating phi 3m to 0, we get mq plus 1 is equal to 0. That implies m is equal to minus 1. So we know that C is given by the equation that C is equal to minus of phi to m divided by phi 3 dash m. So for m is equal to minus 1, we are having that the value of C is equal to minus of phi to m value is minus 2a, so it is minus of minus 2a divided by phi 3 dash m. So phi 3 dash m is equal to 3m square, putting m is equal to minus 1, putting m is equal to minus 1, it is equal to 3. So it is equal to your plus 2a by 3. The value of C is equal to 2a by 3. Hence the equation of the asymptote. So the equation of the asymptote is y is equal to mx plus c. So for m is equal to minus 1, for m is equal to minus 1, and c is equal to 2a by 3. The required asymptote is y is equal to minus x plus 2a by 3. That on simplification it will give you 3y plus 3x is equal to 2a. This is your answer. So the equation of the asymptote is 3y plus 3x is equal to 2a. So next bit is B. Find dv by dt at the point 101 if v vector is equal to cos hyperbolic at I cap plus sin hyperbolic at j cap plus e to the power at k cap. So that means here it is given that. So here it is given that v vector is equal to your cos hyperbolic at I cap plus sin hyperbolic at j cap plus e to the power at k cap, which we know it is a x I cap plus y j cap plus z k cap. So where what is the value of x? X is equal to cos hyperbolic at and y is equal to sin hyperbolic at and z is equal to e to the power at. So here we have to find out dv by dt at the point 101. That means when x is equal to 1, you find out what is the corresponding value of t. So for x is equal to 1, cos hyperbolic at is 1. That implies that t is nothing but t is equal to 0, because we know that cos hyperbolic 0 is 1. So if cos hyperbolic at is equal to 1, then t is equal to corresponding value of t is equal to 0. Similarly, for y is equal to 0, we are getting that sin hyperbolic at is equal to 0. So sin hyperbolic at is equal to 0 means t value is 0. Similarly, for z is equal to 1, we are getting that e to the power 1 is equal to e to the power at, so the corresponding value of t is equal to 0. So that means we have to find out dv by dt at t is equal to 0. So for that, first to find out that what is the value of dv by dt, derivative of v with respect to t, that is equal to derivative of cos hyperbolic at with respect to t into I cap plus derivative of sin hyperbolic at with respect to t into j cap plus derivative of e to the power at with respect to t into k cap. So its derivative is nothing but a into sin hyperbolic at plus it is a into cos hyperbolic at into j cap, and its derivative is equal to a into e to the power at k cap. So we have to find out dv by dt at the point 101. So at the point 101, t is equal to how much? T is equal to 0. So finally we will find out that dv by dt for t is equal to 0, because Cartesian coordinates 101 corresponds to the parameter t is equal to 0. So dv by dt at t is equal to 0 is equal to a into sin hyperbolic 0 plus a into cos into I cap cos hyperbolic 0 into I cap plus a into cos hyperbolic 0 into j cap plus a into e to the power 0 into k cap. So that implies sin hyperbolic 0 is equal to 0. So this portion is equal to 0. So the answer is cos hyperbolic 0 is 1. So it is a j cap plus a k cap. That means it is equal to a into j cap plus k cap. So this is the answer of dv by dt for t is equal to 0.
Thank you.
Next is bit C. Evaluate integration x by x to the power 4 plus 16 with respect to x. It is very simple integration. Here you see that this integration can be written as x by x square whole square plus 16 with respect to x. So here we take this substitution that let x square is equal to t. So since x square is equal to t, so on differentiating we are getting 2x dx is equal to dt. That means we can say that x dx, which is equal to your dt by 2. So on simplification here, on substituting, we are getting that it is half integration of dt divided by t square plus 16. So its integration is tan inverse half tan inverse t plus c, which is your constant of integration. Now we will substitute the value of t. So t is equal to x square, it is half tan inverse of x square plus c. It is the answer. Thank you. Here you see, we have to find out the nth derivative of the function y is equal to log x. So here y is equal to log x. First derivative y1 is equal to derivative of log x with respect to x is 1 by x, that is x to the power minus 1. Next derivative, second derivative y2 is equal to derivative of x to the power minus 1, that is minus 1 x to the power minus 2. Similarly, third derivative y is equal to minus 1 into x to the power minus 3. So proceeding in a similar way. Proceeding in a similar way. Get n derivative y subscript n, that is equal to minus 1 into minus 2 into minus 3 up to minus of n minus 1 into x to the power minus n. Here you see that this minus 1 is multiplied by how many times? N minus 1 times. So on taking minus 1 from each terms, we are getting minus 1 whole to the power n minus 1 into factorial of n minus 1 whole divided by your x to the power n. So it is the answer. That means if y is equal to log x, then its nth derivative is minus 1 whole to the power n minus 1 factorial n minus 1 divided by x to the power n. Is it clear? So here you see, next bit is question number 1e. Evaluate limit extends to pi by 2 sin x whole to the power tan x. In the question paper, there is a printing mistake. Here it is given that x tends to 1 by 2. It is not exactly 1 by 2. That must be x tends to pi by 2. So here you see that we have to find out the limit x tends to pi by 2 sin x whole to the power tan x. So this limit is of which form? Because when x is equal to pi by 2, sin pi by 2 is 1, and when x is equal to pi by 2, tan pi by 2 is infinity. So here you see the limit is of the form 1 to the power infinity form. So how to find out, how to evaluate that thing? So solution that let y is equal to sin x whole to the power tan x. Now taking log on both sides, log y, that is equal to log of sin x whole to the power tan x, sin x whole to the power tan x, which is equal to your tan x, into log of sin x, So now taking limit on both sides, we are taking that limit when x tends to pi by 2. When x tends to pi by 2, log y is equal to limit x tends to pi by 2. Limit x tends to pi by 2 tan x into log sin x. Tan x into log of sin x. So this limit is of the form. It is infinity into 0 form. Because tan 90 is infinity and log of sin x, when x is equal to pi by 2, it is sin pi by 2 1, log 1 is equal to 0. So it is of the form infinity into 0. Now we have to express this as 0 by 0 form. So how can you express? For that we will take that limit extends to pi by 2. Limit extends to pi by 2. It is log of sin x divided by cot x. Because tan x is equal to 1 by cot x. Now here you see that when x tends to pi by 2, this tends to 0. And when x tends to pi by 2, cot pi by 2, that is also equal to 0. So it becomes 0 by 0 form. So we know that whenever the limit is of the form 0 by 0, we can apply L'Hospital's rule. So by L'Hospital's rule, we get that limit x tends to pi by 2. What is the derivative of log sin x, which is 1 by sin x, again the derivative sin x cos x, so cos x by sin x, which is equal to cot x, divided by derivative of cot x is equal to minus cosec square x. So that becomes when x tends to pi by 2, cot x tends to cot 90 is 0. So 0 divided by it is equal to minus 1. So 0 by minus 1 is equal to 0. So we have obtained that limit when x tends to pi by 2, log y tends to 0. So we are getting that limit x tends to pi by 2, log y tends to 0. So take that implies that limit when x tends to pi by 2, e to the power log y, will tend to e to the power 0, e to the power 0 is 1. So we know that e to the power log y is equal to y. So that means limit x tends to pi by 2, pi by 2, e to the power log y is equal to y tends to 1. Now you substitute the value of y. What is y? Y is nothing but, that implies that limit when x tends to pi by 2, y is equal to sin x whole to the power tan x. So that will tend to 1. So it is the answer of this. So next we will consider question number 1f. If y is equal to log sin x, then find the radius of curvature. So we know that the radius of curvature rho is given by rho is equal to 1 plus dy by dx its whole square whole to the power 3 by 2 divided by d square y by dx square. We know that always the radius of curvature is given by rho is equal to 1 plus dy by dx whole square whole to the 3 by 2 whole divided by d square y by dx square. So now here it is given that y is equal to log sin x. Y is equal to log of sin x. So first we will find out what is dy by dx. Dy by dx is nothing but that is equal to 1 by sin x into derivative of sin x, which is equal to cos x. So that becomes your cos x by sin x cot x. Next, second derivative d square y by x square. That is equal to minus derivative of cot x with respect to minus cos square x. Now on putting the values of dy by dx and y by dx square here, getting that radius of curvature rho is equal to 1 plus dy by dx cot x whole square, that is square x, that is cot square x whole to the power 3 by 2 divided by minus of cosec square x. So 1 plus cot square x is cosec square x whole to the 3 by 2. It is cosec qx divided by minus of cosec square x, and that becomes minus cosec x. So this radius of curvature is represents the length. Length cannot be a negative quantity, so omitting minus sign we are getting that rho. Taking the absolute value, getting that rho radius of curvature is equal to cosec x. Because it is a negative quantity, minus cosec x means you take only the absolute value of that thing, that means minus cosec x mod is equal to plus of cosec x. So it is your radius of curvature. Thank you. Okay, here next is question number 1G. Evaluate 0 to pi by 2. In the question paper, wrongly it is printed that from 2 to pi by 2. Actually, it is not from 2 to pi by 2. It should be from 0 to pi by 2 sine to the power 6x dx using Wallis formula. So, what is Wallis formula? We know that if n be even integer, if even integer, then Wallis formula tells that 0 to pi by 2 sine to the power n theta d theta, its formula is n minus 1 into n minus 3 into n minus 5 dot up to 3 into 1 divided by n into n minus 2 into n minus 4 up to dot 2, this whole into pi by 2. This whole into pi by 2 if n be any even integer. Then here you see we have to find out that integration 0 to pi by 2, integration 0 to pi by 2 sine to the power 6x dx. So according to Wallis formula, it will be 5, n is equal to 6 minus 1 5. Next 5 into 3 into 1 divided by your 6 into 4 into 2 into pi by 2. Now 3 and this 6 will be cancelled, here it is 2, so it is equal to your 5 pi divided by 4 into 8, that is equal to 32. So the answer is your 5 pi by 32. Question number 1H. Find the exact arc length of the curve x is equal to sine 3t, y is equal to cos 3t on the interval t belongs to closed interval of 0 to pi. So it is asteroid, which is x is equal to your so this is x is equal to sine 3t and y is equal to cos 3t. Here t is equal to 0, t is equal to 0, t is equal to pi by 2, t is equal to pi. So t is equal to 3 pi by 2, 3 pi by 2, 3 pi by 2. So we have to find the exact arc length of the curve x is equal to sine 3t, y is equal to cos 3t. That means from 0 to pi. That means this arc is A, B, C. So this arc we have to find out the arc length A, B, C. So required arc length is equal to arc length ABC, that is equal to integration 0 to pi, it is arc length is equal to, is given by, its formula is root over of dx by dt whole square plus dy by dt whole square with respect to t. Now it is 0 to pi. So 0 to pi, it is square root of, what is the value of dx by dt? Here x is equal to sine theta, so dx by dt, that is nothing but it is 3 cos 3t. And again, what is the value of dy by dt? dy by dt is equal to minus of 3 of sine 3t. sine 3t. So it is equal to square root of dx by dt means it is 9 cos square 3t, 9 cos square 3t plus 9 sin square 3t with respect to t. So that is equal to 3 0 to pi. So cos square 3t plus sin square 3t is 1. So it is 1 dt. Now 3 integration of 1 is t limit from 0 to pi. So that is equal to your 3 pi. So length of arc is nothing but that is length is 0 to pi. That is 3 pi. Okay, thank you.